All right, let's get right into it. Today, we are talking about a super important topic for any Python developer out there: locking down your Flask applications. Look, Flask is amazing, right? But all that flexibility comes with a catch. Security is 100% on you. So if you're building with Flask, it's time to start thinking like a security engineer. Let's do this.
So, just so we're all on the same page, what is Flask? It's what we call a micro-framework. That means it gives you all the essential core tools to build a web app, but it doesn't really make many decisions for you. And that gives you an incredible amount of power and control. But with great power, well, you know how that one ends.
And this quote right here really gets to the heart of it. Unlike those giant, all-inclusive frameworks that come with a ton of security stuff already baked in, Flask's whole minimalist vibe means the responsibility for authentication, permissions, and attack prevention, that falls squarely on your shoulders. So let's just say it plainly. When you choose to build with Flask, you are the security team. Full stop. Every single choice you make, from how you handle a simple password to how you structure your app's permissions, has a direct impact on how safe your app is. Okay, so to make this whole thing manageable, we're going to approach security like an onion. We'll build our defenses in layers, starting from the inside and working our way out. And that first layer, the absolute core of the onion, is all about securing your user's identity. Who are they? And more importantly, how can you be sure? Let's start with what is, without a doubt, the #1 golden rule of web security. You must never, ever store passwords in plain text. Seriously. If your database gets breached, and you have to assume it might, and you've got passwords just sitting there in plain English, you've basically just handed over the keys to a user's entire digital lives. It's a disaster.
So what's the solution? Password hashing. It's a process where you run a password through a special one-way function, like bcrypt, which you can see an example of here. It creates this secure, totally irreversible scramble of characters called a hash. That's what you store in your database. Then, when a user tries to log in, you just hash the password they typed in and see if the two hashes match. You never, ever need to actually see or store the real password.
Okay, passwords hashed. Great. But how do you keep that user logged in as they click around your site? Well, you've got two main paths: the old-school session-based way or the more modern token-based way, using things like JWTs. And there's a really key trade-off here. Sessions are stateful, meaning your server has to remember everything. Tokens, on the other hand, are stateless. All the info the server needs is right inside the token itself. This choice doesn't just affect how your app scales, it also changes the kinds of attacks you need to be watching out for. All right, let's peel back that next layer of the security onion. We've authenticated our user. We know who they are. But now we have to control what they can actually do. This is where we move from authentication to authorization, and it's a huge step. And this question right here gets to the heart of it all. Just putting a simple login required check on your pages is not going to cut it for a real app. Can a normal user come in and delete someone else's data? Can they just waltz into the admin dashboard? If you don't explicitly define these rules, you're leaving these massive, gaping security holes all over your application. The standard industry-wide solution for this is something called Role-Based Access Control, or RBAC for short. It's pretty straightforward. You define roles, like admin or regular user, and then you assign specific permissions to each of those roles. And surprise, surprise, just like with password handling, this is something Flask expects you to build. It's not included in the box. And here's a perfect, simple example of RBAC in action. Let's say we have a to-do list app. An admin can, delete anybody's tasks, but a regular user, they can only delete their own. This kind of permissions table makes it super clear who can do what, and it makes your app so much easier to manage as it gets more complex. So how does this actually look in your code? Well, it can be as clean and simple as using a decorator. By just adding this little @adminpermission.require line right above a function in your code, you're basically telling Flask, hey, hold on, before you run any of this, you better check that the person trying to do this has the admin role. It's a really clean way to bake your security rules right into your code.
All right, so we've secured our users and we've locked down what they can do. Now it's time to peel back the next layer, defending the application itself from all those common, well-known web attacks. This is where we shift our focus from our own internal logic to defending against external threats.
First up is the classic bad guy, cross-site scripting, or XSS. This is where an attacker tries to sneak some malicious JavaScript onto your site so that it runs in the browsers of your other users. Now, the good news here is that Flask's templating engine, Ginger 2, is your friend. It automatically escapes variables by default, which stops most of these scripts from running. But you have to be really careful you don't accidentally turn that protection off. Next up is cross-site request forgery, or CSRF. Now, this one is a bit sneaky. It's an attack where a totally different malicious website can trick a user's browser into sending a request to your app, a request to do something bad, like change their password or delete their account, all without them even knowing it. And because the browser helpfully sends along their login cookie, your app thinks the request is totally legit. Now, beyond these big-name attacks, we just have to be smart about the data we're handling. Here is a classic, really simple mistake: using YAML.loading on data that comes from a source you don't trust. This one little function is incredibly dangerous. It can literally allow an attacker to run whatever code they want right on your server. And the fix? It's just as simple. The library itself gives you the solution, YAML.safe_load. You should always, always, always use this version when you're handling data you don't have total control over. It's such a simple change, and it closes a massive, massive security hole. So, how do we fight back against that sneaky CSRF attack? Here's your quick checklist. Number 1, use the Flask WTF extension. It handles generating and checking special security tokens for your forms automatically. 2, set the same site attribute on your cookies to lax or strict. And 3, this is a fundamental web rule. Never ever let a simple GET request, like just visiting a URL, be able to change or delete data. Okay, let's move to our final, outermost layer. This is all about the environment where your application actually lives and breathes. You could have the most secure code in the world, but it can still get compromised if it's running on a weak, insecure server. This layer is all about hardening the entire stack. So this last layer goes way beyond just your Python code. Here's a quick hardening checklist. First, encrypt all your traffic with HTTPS. That is non-negotiable. Next, protect your app from bots and denial of service attacks with rate limiting. Tightly control which other websites can talk to your API by configuring cores. If you let users upload files, always clean up the file names with something like Flask's Secure Film Name utility. Lock down the server itself. Limit who can log in. And finally, this one is so critical, always keep your dependencies updated. A vulnerability in some library you use is a vulnerability in your app. Security is not a one-time setup. It's a continuous process.
So, we've peeled back all the layers of our security onion. And I think the big takeaway is pretty clear. With Flask, security isn't just some feature you can bolt on at the end. It's a mindset. It's a whole series of conscious, deliberate decisions you have to make from the moment you write your first line of code. Which leaves us with one final question for you to think about. Your Flask app is built, but is it built to last, or is it built to be breached? Thanks for joining me on The Explainer.